This is equations of motions. Let's read the statement. It says question number 3. A velocity versus time graph. Well, that is important for us to know, because if that is velocity versus time graph, we know that we can work out the gradient. We can also work out the area. So a velocity versus time graph below shows the motion of a projectile. Study the graph and answer the following questions, or the questions that follows. All right, so I can see the graph. So that one there should be my initial velocity. It goes without saying. So allow me to write that V subscript 0. I know you, for initial velocity, you use VI. It's fine, you can use VI. That is initial velocity. Allow me to call this point, you see this point, it corresponds with the time here, time A. Allow me to call here, this is A. That means when time is 0 at the beginning of time, the velocity is 49. And then there is another velocity here at time B. So let's just go put B here next to 2.5. That is that V. And then here at 5, we've got another velocity. I'm just gonna call that one C. Well, that is a velocity, that is when the velocity is 0 here. Remember, time was 0 here. Time was 0. The velocity was way up there. So in other words, I'm looking at the y-axis and the x-axis. All right, and then we've got when velocity is negative 49, you've got another time here. Let's call it alphabet D, that one there. And then we also have here at time 12.5 seconds, the velocity is back to 0. So let's call this one the letter, let's call it letter E. So we were studying this, so we're good. We're good in our studies. So now let's look at the first question. The first question says, what is the physical quantity represented by the gradient of the graph? Well, if I were to tell you, I'll just tell you it's acceleration. All right, so this is going to be, I'll write it as A with an arrow, because you know that is acceleration. In case you are not aware, so we would go for the gradient. We say to do the gradient, we normally do delta y, and we must divide that by the delta x. But when you look into our case, the y is the velocity. So that means we are doing change, delta velocity or change in velocity, and then divide that by the change in time, because that's what we've got on the x-axis. Now, when you look at the equation that is in the orange box, you notice that is an equation for the acceleration, because acceleration is change in velocity over change in time. So that's why we say that is for the acceleration. Well, another way to do this is to take your y. You say, oh, the y is measured in meters per second. So you can just say, okay, my y will be in meters per second. And then you're gonna divide it, you're looking at the units. You're gonna divide it by the time, which is in seconds. So you'll divide that in seconds. When you check the units, they will come out to be meters per second squared. And what's measured in meters per second squared, of which you can also write it in this manner, meter times second to the minus 2. So what's measured in meters per second squared, or in meters per second is nothing else but the acceleration. I think that was a good job done for question 3.1.